Okay, so last week we introduced the hydrostatic equation, and we applied hydrostatic equation to different exercise. Okay, so as the exercise we have done for this problem, we are looking for the U-tube manometers. And the advantage for the U-tube manometer is the diffraction height in here is not larger. So it's more convenient compared to the vertical tube. Okay, the vertical tube will have the higher diffraction and the rising height. So it is very difficult to measure for some conditions with a larger pressure. Okay, so this is another exercise we would like to apply, and this is, we call that the manometer analysis. Okay, so as you can see, the question is how large pressures in here. How large pressure in here? As you can see, that's the pressures of the air in the tank. Okay, so for this problem, we first highlight some critical points. I highlight the points 1 in here is 1, and maybe here is point 2, and here is point 3, and here is point 4. And finally, we go back to here is point 5. Okay, so I highlight the point number from 1 to 5. Okay, so we can apply the hydrostatic equation in here because we know that you from 1 to 2 and 3, they locate at the same liquid, right? So it is at the same, located as the same liquid. That means the constant density. So we can apply the hydrostatic equations. The first is the P1 plus the gamma Z1 will be equal to P2 plus gamma Z2, right? And here the gamma is mercury. You see here is the mercury. Okay, the liquid is the mercury. So I use the gamma N in here. And we can distinguish different liquid. We will have a different specific weight. Okay, so just make the balance, because the P1 is located at the atmosphere environment, so the gauge pressure is equal to 0. So we know that actually the P2 is equal to the gamma N and Z1 minus Z2, and here the Z1 minus Z2 is equal to L3 here. Okay, so we know that this is the gamma N and the L3. Okay, and because the location 2 and the location 3, they are located at the same liquid and with the same elevation. Okay, so we can say that the P2 is equal to P3. P2 is equal to P3. And then another condition is we start from the 0, 3 and go through the pipe to the 0, the point 4. And the media in here is the gas air. It's the gas air. So we make another balance for the point 3 to the point 4. So we write the equation, the point 3 plus gamma air. I use the gamma air. I use the gamma A, and the D3 is equal to the P4 plus the gamma A D4. Okay, and our purpose is the how large pressures of the P4. So we reorganize the equation. We put the one side only for the P4, and the P3 plus gamma A and the D3 minus D4. Okay, and as you can see, the D3 minus D4 is the negative values because the D3 located here and this is the D4. So you can rearrange. It's equal to the P3 minus the gamma A, and the D4 minus D3 is equal to L2. And you put the P3 inside in here. Okay, you have the P3 in here, and we just replace the P3 by the gamma N L3 minus the gamma A L2, right? So the final balance we would like to from the 4 point and going to the 0.5. And they are located at the same liquid, right? The liquid is oil. Okay, so we can also make another balance is the P4 plus gamma Z4 is equal to P5 plus gamma Z5. And the gamma here, we use the oil. So I use the gamma O to indicate the specific weight for the oil liquid. Okay, so the P5 is our final solutions. So we make the balance is equal to P4 plus gamma O and D4 minus D5. And we keep the P4, and here the gamma 0 oil O in here, and the Z4 minus D5 is equal to L1. So here I use the L1, and we have the P4 in here. Okay, so we put the P4 for our final equations. So here is the gamma N L3 minus gamma A L2 plus gamma O L1. So based on these equations showing here, okay, and the P5 is our final purpose. It's our final purpose. So I would like to summarize again, because from 1 to 2, the elevations is decreased. So we have the positive gamma L. And from 3 to 4, the elevation increase. So we have the negative gamma L. And the final one, we from the 4 to 5, the elevation is decreased. So we have additional positive pressures. So conclusion is, if the elevation increase, and the pressure will minus. And if the elevation decrease, the pressure will positive. So you can, based on this idea, to quickly to calculate the P5. Okay, so right now we put all of the number inside the equation. So P5 is equal to gamma n. The gamma n showing here. The gamma n showing here. So 133.000 Newton meter cubic multiply L3. L3 in here is 80 centimeters, so equal to 0.8 meter. Minus the gamma A. Gamma A is the specific weight of air, right? So it's equal to the density multiplied the gravity constant. So the air density is 1.2 kilograms per meter cubic, and the multiply G is 9.81 and a meter per second square, and finally multiply L2. L2 is 100 centimeter equal to 1 meters. So multiply 1 meters. And the plus the gamma oil, but we don't have the gamma oil. So you see here we have the specific gravity S. So the gamma oil is equal to the S 0.8 multiplied 98110 Newton meter cubic, and multiply L1. L1 in here is equal to 0.4 meter. Okay, so you can use the calculator to compute the final answers for these questions. So because of the time limit, so I just you can check it by yourself. So I just write down the answer showing here. Okay, and the gauge is the gauge pressures. The pressure is, we use the unit is the gauge pressures. Okay, so you can double check by yourself. So the idea for these questions, just follow this idea. Okay. How about the idea? The idea showing here is if the elevation is the down, so you have the positive pressure changes. If the elevation is going up, you have a negative pressure changes. Okay, and depend on different liquid, you have a different gamma. Different liquid, you have a different gamma. So you need to take in considerations the different liquid. You cannot use the hydrostatic equations. So hydrostatic equation only satisfy for the same liquid with the constant density. Okay, so this is another idea. As I tell you, the flow is from left and the flow to right. Okay, so that indicates the pressures in location 1 and the pressure located at the location 2. Here we have the higher pressure at location 1, and here we have a lower pressure at the location 2. That's why the pressure difference between the 1 to 2. So the reason why the flow will flow up from the left to the right. Okay, from the left to the right. So the idea in here, how difference pressure between the 2 and 1. Okay, so again we make the balance. The first we start from the point 1, and we just move down. And how the deflection height in here, we have the deflection height delta H in here, and we know that there is the delta Y. And as I mentioned, because the going down, so the pressure is the positive increase. So you see here we have the gamma A. The gamma A is the specific weight of the flow liquid. Okay, and then we have the elevation decrease for this delta 1 plus delta H. And then that's why we use the positive in here. And then we are located in here. Okay, we first going down here, and then we would like to go right and then go up and in here. Okay, so because the elevation for the delta H is increased, so here we use the minus and with the delta H gamma B, because this is our manometer liquid is fluid B, we use the fluid B. Because the elevation delta H is increased, so we use the minus in here. And the final one, we would like to from here and go up to here, point 2. Because the elevation also going up. So as you can see, there is the delta H and plus the D1 minus the D2 minus D1. And we still use the minus symbol in here. So elevation increase, the pressure decrease. Elevation decrease, the pressure increase. Okay, so you see, we just based on this equation and then make the final balance. We put the all of the parameter related to the point 1, we merge together, and related to the point 2, we merge it together. And this one, the first one, we call that is the piezometric pressure. This is the piezometric pressure 1. Okay, usually we use the PZ1 and the PZ2. So based on this equation, the first item is the piezometric pressure 1 minus piezometric pressure 2 is equal to the gamma weight difference multiply the delta H. Where is the delta H? Delta H is here, the deflection height for the manometer liquid. Okay, and if you divided the equation by the gamma A, and the final solution is equal to the piezometric head. OK， 所以1到2的压差的测压压差，其实就等于它们的单位重的差距乘上被抬升的高度。那如果你把这个方程式除上伽马 A 的话，其实你就会得到什么？水头差，测压水头差。测压水头差，就是说它们的测压水头差其实就是把就会等于这个 ratio 减1乘上扰动的这个抬升的高度。Okay, so this is the common situation we have. Okay, so we can quickly do this exercise because we already know what are the questions. The question is find the changes in piezometer pressures and the piezometric head. Okay, so I would like to compute the piezometric 1 minus the piezometric pressure 2. As I mentioned, based on the equation shown here, I know that the difference is equal to the delta H and multiply the gamma liquid B in here minus the gamma liquid A. So you can double check the equation shown here. Okay, shown here. So how about the delta H? Delta H in here, the question tell you is equal to 1 inch. The 1 inch. And so we know that the delta H is equal to 1 inch. And we know that the 1 inch is equal to 2 0.54 centimeters and equal to 0.0254 meters. And how about the gamma B? The question tells you the flow is the water, and the manometer fluid B is the mercury. Okay, so we have the mercury. So we know that the gamma B is the gamma N in here. This is the mercury specific weight showing here, and the gamma W in here. But you notice that the dimensional in here, I use the English English unit. So maybe I need to change the 1 inch is equal to 1/12 ft, right? 1/12 ft. Okay, so I just put the English unit inside. So this here is a 1/12 ft. The gamma B is the gamma N. So here is a 847 pound force versus ft cubit minus the gamma W is the 62.4 pound force divided the ft cubit. Okay, so you can compute the answer for the this English unit. So 847 minus 62.4 divided the 12. So the answer is around the 65.4. And based on the unit here is pound force, ft squared. So the unit is the PSF. Okay, the PSF. And the second question is, how about the piezometric head? Piezometric head. That means the piezometric head difference. Okay. So our purpose is calculate the H1 minus the H2 piezometric head difference. And as we know that the piezometric difference is equal to the piezometric pressure difference divided the gamma water in here. Divided the gamma water in here. Based on the equation showing here. Okay, we just divided the gamma A flow fluid. So the answer in here is we have the 65.4 PSF divided the gamma W is the 62.4 pound force divided the pound ft cubit. So you use your calculator is around the 1.05 ft. Okay, so the two answers showing here. So if we actually know the equations showing here, so we can compute the pressure, piezometric pressure difference very quickly, just based on the how deflection height showing here, and how the specific weight difference between the flow fluid and the manometer fluid. OK， 所以这个公式是由hydrostatic equation 推导过来的。如果你已经知道这个公式的存在，其实你在算管子内的两点的测压变的差异的时候，其实套这个公式马上就会得到答案。然后其实观念上很简单，你一定是比较高压在这里，所以你会去压管子里面的液体，所以这里才会抬升起来嘛，对不对？这里的压力比较大，你去压那边才会抬起来嘛。所以其实你光看抬升的高度，你就知道哪里是压力大的地方。OK， 那我想今天时间很有限，今天的内容我们就上到这里。那其实我们刚刚教的